both Giorgio and Roberta joining us from the Cultural Heritage Technology Centre of IIT in Venice, where Giorgio is a computer science engineer, solution architect and full-stack developer, and Roberta is a postdoctoral researcher in conservation chemistry. Giorgio specialises in the design and implementation of advanced information systems, including web applications, dashboards and control panels, utilising the latest and most secure front-end, back-end and database technologies. And his current work is focused on prototyping a decision support tool for restorers, which he'll be speaking to us about today. Roberta specialises in the study of the corrosion mechanism of ancient glass and their progression using multi-analytical techniques to investigate materials from the microscopical to nanometric scale. Her research is currently focused on the design of nanomaterials as protective coatings. I could have got you to speak those slides. To stop the alteration process, limiting the interaction between the surface of ancient glass and its conservation environment. Thank you.
Thank you, Claire, for the introduction. Thank you all, and thank you again, Claire, and your team for preparing this workshop. And so now, together with Giorgio, I'm going to explain you the DSA app, so the digital support hub that we developed during within the GoGreen project. And I'll start with a brief introduction on the methodology that we used to develop this app, and then Giorgio will explain you and will show you the different sections of the app and how it works. So the first things that we did was to clarify, to clearly identify the problem we needed to address. Because in the conservation fields, many materials look very similar, and they can be used for the same type of treatments. But in reality, some of them have a much higher environmental impact than others. And so today, conservators and restorers doesn't have a simple, accessible tools that help them compare these materials and shows the more sustainable option. And a clear very example is the acetone versus bioethanol, because from a practical point of view, both can be used for similar cleaning operation procedures, but their environmental footprint could be it's very different, because acetone has a significantly higher impact, while bioethanol is generally considered a greener and safer alternative. This kind of difference is not always obvious, and the professional often have to really or partial information about these the sustainable data of this material. So the greener the GoGreen hub could be meet the solution of this problem, because the goal is to identify all material used in conservation and evaluate their impact using clear and internationally recognized criteria. The result will be the creation of a trusted tool that supports conservators in making informed and responsible and sustainable decisions in their daily practice. In this holistic approach, the app will not give a preference of using one treatment instead of another, but it will give an evaluation in terms of greenness of the materials or treatments. Therefore, it will offer a comparison between individual materials or treatments based on the assessment of selected green parameters with the GoGreen projects that we will see later, and that when already well explained and mentioned before. The strategies that we follow for the developments of the app was also structures. So we started with the definition of the end user requirements by an online survey. Then we collect online and offline data useful for the material and the treatment evaluation. And then by collecting this information, we designed the platform carefully considering the user's needs and the project's aim. Finally, the app was evaluated by end users in order to collect feedback for the last implementation phase that's ongoing now. For the test for the app design, we ask ourselves when conservators can use the app. And considering the conservator decision phase, there is a time when they decide to proceed with the treatments of an object. There is a testing phase that starts when the materials selected for treating the object will be are tested in order to meet the goal and the safety of the object itself. So within the testing phase, conservators can consult the app to know the greenness of the material selected for the treatments. Moreover, the app can be consulted anytime a conservator wants to be informed about the greenness of a material or treatments for their practice. So following this decision-making process, the designing forward flow of the app involves the conservators entering the material or treatments they intended to use. Then the app provides a score for each material or treatments that are evaluated for all the green parameters selected and defined within GoGreen. And as final output, the conservators have a comparison between materials and the awareness of which treatments they intend to use is greener. As mentioned by Gwen, the app will evaluate the material or treatments using the GoGreen green parameters that are reported summarized in this table, that are grouped in 4 categories. So there is the first one that are related to the impact on humans and environments. So here we analyze the toxicity, the health risk, and environmental hazard. The second group is related to the impact on climate change. So this category is focused on elements connected to energy and emission, for example, the indoor climate control needs, the energy consumption during the treatments. And so these parameters help us to understand how a material contributes to the climate change throughout its use. The third groups are related to the impact on the resources, because it's very important and essential to consider the resources required to produce and use these materials. For this reason, we evaluate, for example, the water use, the resource depletion, the impact on biodiversity, and the amount of the waste generated during the treatment. Finally, there is the final group, the fourth group, that is the one related to the professional parameters that depends directly on the conservation fields, so the conservation activities. And through for these parameters, the app asks inputs from conservators, restorers that use the app, related to their specific work conditions and habits. For example, the climate latitude, the material availability, the cost, and the type of treatments they are performing. So these parameters allows the assessment to be personalized, reflecting the real work scenario of each user. To evaluate each of the green parameters, individually we set up a main app logic. And in this slide we can see the 3 main data sources that we use for create the final assessment of the parameters. On the left we have the life cycle assessment, so the LCA data, which reflect everything that happened before the material is used, such as the extraction of raw material, the water and the land use, the transport, and the energy consumption. Then we have the toxicity data that focus only on the effect on people and on the environment during the use of this material. And then on the top we have the inputs from the user, which are used for the evaluation of the green parameters related to the professional of conservations. I switch directly on the final phase, because then I leave the floor to Giorgio for show the app in more details. So in the final phase of the step of the app developments, we perform a testing phase. So the app was tested by a lot of users, And we collect feedback using a survey, an online survey. And this feedback, now we are using this feedback to implement the data, the app, considering the data collected. So I would like to thank, first of all, the DSA team, and then I leave the floor to Giorgio for presenting the app. Okay, fine.
Thank you very much. Thank you all. Nice to meet you. Okay, now I'm here to present the technical part of the application when Roberta has explained in a great way all the project. But now I try to not bore you about the technical part. But this is for this presentation we decided to skip the PowerPoint and to show you the app in action, really in action, okay? Because this is the first, the really first time we should show the app publicly. So we thought that this is the better way to interest you in this part of the project. So actually, pay close attention because we are going to use the application with you. So what's happened? We just simply type a URL, and what's happened? Oh, so yes, you have to remove these on the PowerPoint. Collaborate.
Okay.
Oh, I destroy everything. Okay, I'm a good technician. Okay, just with a simple URL, we enter this application. You see that it is a classic, normal website with the top bar menu, with some content, with some shortcut to the most important part of this application. Home, about, tools, everywhere here you can find all the information about this project, the consortium, the partners, some links of external partners, of course, and resources and what else. But we really want to show you today the last voice of this menu, that is the workbench. The workbench is a credential protected section of this application where every user can enter with his credential, entering inside a private area where they can define materials, treatments, and some of their work information in order to receive by the application some green evaluations. So that's right. We enter in Workbench. We have, of course, a login page. Mario Rossi. Oh, Mario Rossi is a typical Italian name. Is your English John Doe. Okay. So, with these credentials, we enter inside the Super Mario private area. Oh, we already have something. Now I want to show everything. Let's try. Remove these. Oh. So entering private area, we can see that there is a top banner with two main sections, the product comparison and the workspace. Let's take a closer look at each of them. The product comparison inside this, as suggested, we can press this button and select two or more materials to compare together. This is a beta version of the application, so we for now have only 12 materials, but we plan in the future to expand this list as much as possible in next upgrade of this application. So here we can select, for example, two solvents acetone and ethanol, or some resin, or some detergent, or some tool. So let's try acetone and ethanol. I accept them, and pressing done, we arrive inside the comparison view. So we're finished. This is the biggest great job, Giorgio. Okay, this is the final. But what's happened here? Okay, let me say you in a better way. So, something very important to understand in this session is that the circle evaluation, as you can see, the color of the circle evaluation came from the LCA data processed in partnership with the Stitch software of the American FIC, and the triangular evaluations, on the other hand, refer to the toxicity impact of some materials, and they derive from the up-to-date toxicity data, such as those provided by the GHS, for example, the Global Harmonized System. Here we can, of course, understand, just check that ethanol is better than acetone in some way, in some, but not for the G6 parameter. Why not? Because it refers to the water consumption. In fact, the acetone needs a lot of water to be produced, because the circle assessment are refer to the production of the material. So in this case, acetone is worse than ethanol, but in the other parameters, it is the opposite. Why we are seeing only these 5 green parameters, not the 14 we have said before, because this is only a product comparison. It is not it has not all the information needed for the comparison inside the treatments, because we don't have the amount of this material used during treatment or other user input. So this is an absolute comparison due only by the CA data, and also the hazard assessment. For every one of these parameters, we can press it and expand the row and see what's happened about this assessment. There are some numbers that I don't want to enter more deeply in this, but of course we see that the acetone is worse in LCA assessment, but it is worse also in hazard assessment. So it's better only to use, of course, the ethanol. And in this view, we have also, for the parameters G1, G2, the graphic view. That is another way to see the same results, but okay, we are sure that this is the better solution, this is the worst, and the same for the CHA, the hazard assessment is another way. But what we want to see today is the treatment comparison. It is the workspace. Yes. The workspace is another part of the user private area, and is a space, an open space where we can define some folders. And the folders are referred to the conservator tasks, for example. So here my Rossi is working on a Roman mosaic in this case. But let's create a new folder. Here we are. Folder number 4, but we can rename it. What we want to do, some tasks for example, or we want to work in some painting. Cleaning. We want to clean some painting, for example. So, pressing this button, we enter this folder. We are in the cleaning painting, okay. And the app suggests us to, the folder is empty, and we have to press this plus button. Okay, thank you very much. I press twice, because I want to create 2 treatments, in this case. 2 or 3 or more of what you want. Because you want to try different treatment for the same task and want to find out what is better. So the app suggests us to press this select the materials button, that is the same as before. And just I want to do something before. I want to rename 321. 321. I want to rename it with acetone. And the treatment 2, I want to use ethanol. Fantastic. So material. So acetone, I want to use some cotton, for example, and done. And for the treatment 2, with ethanol, so ethanol and ethanol. Okay. Here we have the materials inside the treatment. Here we can also select the single materials as we have done before, acetone and ethanol, and compare them, pressing compare. It is the same screen as we saw before. As a comparison. And also we can select the entire treatment and try to compare them. But the app is wanting us to press those buttons to fill more inputs. You remember we talked about that the app needs a lot of inputs about the user to understand what are these treatments. But I want to try to compare them. Okay. As we can see now, we have all the 14 parameters, but there are a lot of gray circles because we also in this case we can compare only the G1, G2, G5, and G6 as before because they are referred on the DSA data. All the gray dots are referred to the user inputs. So we must enter in this button for the first treatment, and here we have many inputs about the user. Some are always under construction, but let's take a look on someone. For example, the quantity. The quantities are important. How many acetone we want to use? 300 milliliters, for example. Here we are. And the cotton, 500 kilos, no, grams. Save. Yes, and now the sign is green, so we are sure we have input. The G3, the imaging door climate control, asks us will the treatment increase the need for climate control of the object. We can say yes, no, or moderate. We say yes. And so on. So we have more yes or no, choose something to choose. I don't want to stress you more, but I love this parameter because here this is the most complex one. Do you really have all the necessary materials? If I say yes, it's a good thing because I don't need to destroy the world to have more materials. I have already in my hand. Yes. Okay. For the app is okay. Is save. After we can just now we can say we can show that if I don't have the materials, the application asks me one more question: are they available you to purchase? If I say no, the app say okay, you don't have materials, you cannot purchase. I cannot evaluate this. So it's impossible. So it remains a gray dot when we saw it. But if I can purchase them, another great tools teams app. I say yes. The application asks me the supply location, the treatment location. Oh, sorry, okay. I'm sure that I'm buying the acetone that is produced in Roma, was produced in Roma. I tape Roma, and press enter, and something happened in the internet. He proposed me these three locations. Yes, Roma, Capitale, Lazio, Italia. Yes, is right. And where is my laboratory? Is in London. Okay. Where London, City of London, Great London. Okay, perfect. City of London. This is, and this is the distance. We have used some formula to calculate the line distance from Rome to London, 1,433 kilometers. Of course, this doesn't give us the information on how these materials arrive from if by train, by ship, or what else. But it is a measure, is a parameter. The application, of course, prefer materials that are purchased near the laboratory instead of the other part of the world. And also the cost of material, okay, say changes, and so on. We can define all these inputs probably in this afternoon.
Yeah, probably, yeah.
We are
Not to discuss.
we are planning,
Yeah.
we are planning this afternoon to let you use the application if you want with us, so we can show better everything. Let's enter in Roma side, because here I have already input everything, so now we finally can select the two materials, the two treatments, and press compare. And here we are, all 14 parameters and a lot of colored dots. But also there is something gray. This is because let's take a look. Let's expand the G13 parameter. And why they are gray? Because here we have defined the same parameter. It is but the easy to use. It is easy application. What the time for testing, the time needed for the treatment. So they are similar. They produce just the same value. So they cannot be compared together. There is no one better than the other. So they are gray. But on the other hand, we see a lot of differences, and now we want to stress you that these are not absolute rules. These are simply indicators to support the experience and the judgment of the conservator. So you can do your evaluation on your own. So what have to say more?
Maybe.
I think we have. Yes. So, okay, we have given you a quick overview. This afternoon we try to use it together. As I mentioned, we have to improve this application, the logics, or we have to take care about the what came out about the testing phase. Which highlights some possible change for better usability and clear results. So that's all for us. Thank you so much for your attention. If you have any questions, we are happy to.